Hi there, this is an Algebra 1 video. It is Chapter 4, Section 7. It is the last section of the chapter. And so, not to scare anyone or anything, but just so that you're aware. And this lesson is over inverse linear functions. And first and foremost, I want to give you a definition of an inverse relation. You will recall that in the past we've had relations, and relations look like sets of ordered pairs. They have, the little brackets, and then there's all the ordered pairs. And we'll see that in the examples in a few minutes, but first I want to give you a definition. So an inverse relation, it says here, is a set of ordered pairs, so that's why it's going to look like this. And it is obtained by exchanging the x coordinates with the y coordinates of each ordered pair in the relation. So it's not that complicated. Basically, all you're doing is you're going to switch the x and the y coordinates, and that's how you get the inverse. So basically, if one relation contains the element AB, then the inverse relation would contain the element BA, because you would switch the x and the y coordinates. And we're going to see that in our first example. So here we have two examples here in black, and those are the ones that I'm going to do, and then you will do the do-it-yourself number one. So here we go. You can see from this relation that we have 1, 2, 3, 4 ordered pairs, and in order to get the inverse relation, it's really simple. All we're going to do is we're going to interchange the x and the y. So we're going to put the y in the x's place and the x in the y's place. So for our first ordered pair, instead of 4, -10, we're going to get -10, 4. Instead of 7, -19, we're going to get -19, 7. Instead of -5, 17, we're going to get 17, -5. And instead of -3, 11, we're going to get 11, -3. So what's happening here is you have an x coordinate that goes in as a 4, comes out as a -10, but then it goes in as a -10 and comes out as a 4. So it's kind of, that whole going backwards process. And we'll explain that a little bit further in example 3. But that's basically the relation. You can also do that with an ordered pair situation. And it just means that we're going to switch the x and the y. So what you want to do in this case is, even though you are switching the ordered pairs, you can still write them as a relation as opposed to a table. So actually I want to, where's my eraser? For a minute there I'm looking for my eraser, like the actual eraser as opposed to the virtual one. That was kind of weird. But okay, so what we're going to do is the same exact thing. And here we have -4, -13, so we're going to go -13, -4. And then instead of -1, -8.5, we're going to put -8.5 in the x's place and -1 in the y's place. And then we're going to put 0.5 in the x's place and 5 in the y's place. And lastly, 6.5 in the x's place and 9 in the y's place. And we barely made it there. Okay, and that's pretty much as complicated as it gets for this example. So now I want you to try do-it-yourself number 1, and then we'll move on to example 2. Now in example 2, they want us to graph the inverse of the relation. In order for you to be able to graph the inverse of the relation, you actually have to have the ordered pairs first. So the first thing you want to do, and in your diagrams in your textbook, they don't actually have the nice little points that I put here on the graph. I went ahead and looked at the example and saw the places on the graph where it looked like it was a clear indication that that was the right point. Remember that you don't want to pick points that are not in an exact crosshatch on your graph. But I've done that for you already. So basically, in order to graph this, we have to come up with some of the ordered pairs that exist in the normal graph. So, for example, I've got 1, 2, 3, 4, 5 different points that I found from the graph. And the coordinates of those points are going to be 1, 2, 3, 4, x is -4, and y is -3. I'm also looking at -2, -1. And then I have 0, 1. And I have 2, 3. And lastly, we have 1, 2, 3, 4. No, 1, 2, 3, and 1, 2, 3, 4. So 3, 4. Okay, so those are the points that are already on the graph, but I want to graph the inverse. So the first thing I have to do is take these points and invert them, exchange the x and y's. So the actual inverse relation will be the inverse of all of these. So it'll be -3, -4, -1, -2, 1, 0, 3, 2, and 4, 3. Okay, so now we've inverted everything, and now I can actually plot this, and that's pretty much all you have to do. So now I'm going to come to my graph, and I'm going to say, okay, where's -3, -4? So 1, 2, -3, and then -4 is 1, 2, -4 is right about here. So right about there. Then we're going to get -1, -2, right about there. Then we're going to have 1, 0, 3, 2, 1, 2, 3, 2, and 4, 3. 1, 2, 3, 4, 3, somewhere right there. And then we're going to graph that line. And then I want to show you something that's actually pretty important when it comes to these graphs. Put together my points here. Get my points a little bigger so you can see them. -1, -2 is right there. 0, 1, sorry, 1, 0, 1, 2, 3, 2, and 4, 3. Right about there. Oops. Okay, so there's my graph, and so now I've graphed the inverse. So this function here is y, and this is y inverse. And we'll talk about that in a second. So basically, one of the things that I wanted to show you is that when you graph a function and its inverse together on the same set of coordinate axes, you should always have that the two graphs will be mirror images of each other when you draw the line y equals x. So if you remember, y equals x is the identity function for functions, and so if you graph y equals x, it means you're going to graph 0, 0, 1, 1, -1, -1. So it's going to look kind of like alrighty. What I'm graphing right now is actually y equals x. Okay, so the red line that's going down the middle, this dashed line, is y equals x. And when you graph a function and its inverse together on the same set of coordinate axes, you should always get that the two graphs should be mirror images of each other when you put that red line through the middle of them. Okay, so that's just a tidbit of information for you. I want you to try that as you do it yourself. Number 2, there are two graphs here, and when you graph y equals x, which will go right down the middle like this, you should have two lines that will be mirror images of each other. And again, I will show you that a bit further when you come back into class and we'll do the do-it-yourself questions. But I want you to try that. Okay, so then we have our last example and topic here, and that is how do you find the inverse function? So first of all, you saw me do this a little while ago when I put y and y inverse. First I'll talk about notation. We already know that we have notation like this, f of x, and you read it f of x. It doesn't mean f times x, f parentheses x, it's f of x. So this notation is not f to the -1 power, it's not f minus 1, you're not subtracting 1 or anything. This just represents inverse. So when you read this, you read it f inverse of x. This is f of x, this is f inverse of x. So we want to find the function that would be the inverse. And it has a lot to do with how we interchanged x and y earlier when we talked about ordered pairs. And so what I want you to understand about an inverse is basically that it means to go backwards. All right? So for example, when you talk about this function, we can talk about f of any number we want. I'm just going to go ahead and pick 3 just because it doesn't really have any reason, but 4 times 3 minus 8. This is a function, and a function is like a machine. It tells you to do something to the number. So when I say f of 3, that means that I'm going to put a 3 into my function, and my function is going to do something to it, and when my function spits out the number, it's not going to be a 3 anymore. So what happens is, the 3 goes in, and the machine tells me to multiply that 3 by a 4, which now gives me a 12, and then it tells me to subtract 8 from that. So 12 minus 8 is now 4. So what happened is that in this case, the machine took my 3 and turned it into a 4. Okay? And so now what I want to do, what I want the inverse function to do, is I want the inverse function to undo all the things that the original function did, so that I get back to my 3. What if I made a mistake and I want my 3 back? So how do I get it back? I have to go backwards. So since the last thing I did was subtract 8, I could probably find a function that would take my x value and it would add 8 to it because I subtracted 8 from it. So it would add 8. That's the inverse of subtraction is addition. And then instead of multiplying that by 4, I would divide by 4 because I want to do the opposite. So I am proposing, suggesting that the inverse function would be this. Now this is all mental math. I'm going to show you in a second how to do this algebraically, but mentally you can probably figure this out. So I want to check if this works. So according to my machine, I have f inverse of a value. Okay, so remember, I put a 3 into this function and out came a 4. So I want to take my 4 from earlier, and I want to see if this machine will undo all the things that that machine did. So the 4 goes in, okay, and what's going to happen is I'm going to take 4 plus 8, which is 12, and 12 divided by 4 is now 3. So I hope that you can see what's happening here. Over here, we had x coordinate 3, y coordinate came out of 4. I put the 3 in, a 4 came out. Over here, I put a 4 in, and the 3 came out. First of all, you can see how the machine did in fact make everything go backwards, and it gave me back the original number that I had, which was a 3. Also, you can probably see now why we interchange x and y in the original example that we did first off, the number 1, where we interchange x, and this is y, because this is what happens when you have an inverse function. Okay? So basically what ends up happening in these cases is that the domain of the function, the x coordinates, the domain of this function, ends up being the range. And I can show you that again in example 2. You can see that really clearly. Domain is all the x values. So the domain here is 4, 7, negative 5, negative 3. But then that becomes the range of the inverse function. 4, 7, negative 5, 3 is now the y values. So basically the domain and range kind of change places too when you're doing inverses. All right, so now what I want to do is, with this same example, I want to show you how you can get this by using algebraic steps instead of doing mental math. So to do that, we're going to have one more example here, example part B. And again, we have a function, f of x equals negative 1/2 x plus 11. And there are basically 4 steps that we want to do. So I'm going to tell you those right now. So step 1 is to replace f of x with y. f of x is just a fancy way of saying y. So instead of writing f of x equals negative 1/2 x plus 11, I want you to write y equals negative 1/2 x plus 11. And that's the first step. Okay? Step 2 is for us to interchange x and y just like we interchanged x and y in the ordered pairs in example 1. All right? So that means that instead of it saying y equals negative 1/2 x plus 11, it's going to say x equals negative 1/2 y plus 11. Then step 3 is going to be to solve for y. So now it says x equals negative 1/2 y plus 11. And I'll rewrite that over here. And now we want you to solve for y. So to solve for y, I'm going to subtract 11 from both sides. So I will get x minus 11 equals negative 1/2 times y. And to get rid of the negative 1/2, I will multiply both sides by negative 2, because negative 2 times negative 1/2 is positive 1, and that will leave me with y, which is what I wanted. I wanted to solve for y. And over here, negative 2 times x is negative 2x, and negative 2 times negative 11 is positive 22. And so that's step 3. And our last step is just to put the f of x notation back into the problem. So step 4 is going to be to rewrite with f inverse of x. So instead of it saying y equals, we're going to say f inverse of x equals negative 2x plus 22. And that would be the inverse function for negative 1/2 x plus 11. Alrighty, so that's how you do it. And you can even attempt those 4 steps in the previous example very easily. I want to show you that it does work in both cases. Remember, step 1 was to write it as y equals 4x minus 8 instead of f of x equals. The second step, was to interchange x and y. So x equals 4y minus 8. Our third step was to solve for y, so I add 8 to both sides. I get x plus 8 equals 4y. Divide by 4, and you get y equals x plus 8 divided by 4. And then our last step was to put it back. So we did all that. We did the interchange x and y. We solved for y. Then we rewrite it. And I get f inverse of x equals x plus 8 divided by 4, which was what we had mentally done earlier. We get the same equation. So that's how you find the inverse function algebraically. So now I'd like for you to try these 2 do-it-yourself questions on your own. And once you have done that, you will have completed your notes for this lesson. And I will see you in class, and thank you for watching.